In November 2019, the Event Horizon Telescope captured the first photograph of a black hole, M87*, 55 million light-years away. But what astronomers saw wasn't what equations predicted. The light bending around it was far more violent, far more extreme. By the end of this, you'll understand why ancient astronomers may have glimpsed something similar, and what that means for everything we thought we knew. Black holes weren't always accepted as real. In 1783, John Michell calculated that a star massive enough could trap light itself, a dark star. 30 years later, Pierre-Simon Laplace independently arrived at the same conclusion. But for nearly 2 centuries, physics dismissed them as mathematical phantoms. No object could be that dense. Not until Einstein shattered everything. In 1915, Albert Einstein published General Relativity, and buried within it was a terrifying prediction. Massive stars, when they died, wouldn't simply fade. They would collapse into themselves infinitely, creating gravity so intense that not even light could escape. The equations were elegant. The implications were impossible. But Einstein himself refused to believe what his mathematics revealed. In 1939, Robert Oppenheimer and Hartland Snyder proved stellar collapse was inevitable. A star massive enough would collapse completely. But they made a shocking assumption. It would happen in seconds, invisible, undetectable. How wrong they were. Keep this timing in mind. What actually happens is far slower, far more terrifying than they ever calculated. For decades, physicists refused to believe black holes were real. Until 1971. Cygnus X1, a binary star system 6,070 light-years away, began behaving strangely. X-rays were being emitted from something invisible, a presence that could only be explained by one impossible object. The first black hole had been found. Everything about what was possible changed in that moment. But discovering Cygnus X1 raised a question that physics still can't answer. How many black holes exist? The answer is staggering. Not thousands. Not millions. Billions, possibly one for every star system in the observable universe. And they've been there, waiting, for over 13 billion years. This detail becomes crucial to everything that follows. The term black hole wasn't coined until 1967 by physicist John Wheeler. Before that, scientists called them gravitational collapse objects, clinical detach. But Wheeler's phrase captured something equations couldn't. The absolute void, the unreflective darkness, the boundary between existence and non-existence. Within a decade, we'd find real ones. The name had become prophecy. In 1963, Roy Kerr discovered a mathematical solution predicting something impossible: rotating black holes. Not stationary, not inert, but spinning at nearly light speed, their gravity twisted and distorted. These Kerr black holes would have not one event horizon, but two. A passage that theoretically might lead somewhere else. Physicists called them wormholes. But no one survived to prove they work. In 1974, Stephen Hawking made a discovery shattering 30 years of black hole theory. Black holes weren't truly black. They emitted radiation. A quantum effect near the event horizon would cause black holes to slowly evaporate, a process taking trillions of years for stellar black holes, but billions for smaller ones. This meant every black hole in the universe was dying. and we never knew they were alive. The discovery that changed everything came in 2015. LIGO, the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time. Two black holes 1.3 billion light-years away had collided and merged. LIGO detected ripples in spacetime itself, a phenomenon Einstein predicted but thought too faint to measure. He was wrong. And this is where the ancient mystery begins. We're halfway through, and what comes next is why I made this video. Because in 2020, 3 astronomers won the Nobel Prize for proving black holes weren't anomalies. They were everywhere. And we found something in our own galaxy that changed how we understand gravity itself. Something that shouldn't exist. At the center of the Milky Way, 26,000 light-years from Earth, lies Sagittarius A. For decades, astronomers detected violent radiation, massive stellar orbits, gravitational forces that defied explanation. In 2020, Andrea Ghez and Reinhard Genzel confirmed the source, a supermassive black hole, 4.1 million solar masses. It has existed for 13 billion years, and it is still actively feeding. Yet here's what physicists couldn't explain. Sagittarius A is dormant compared to other supermassive black holes. Yet even dormant, it consumes 26,000 Earth masses per year. Every single year. Objects are being torn apart. Stars are being shredded. We can watch it happen in real time if we know where to look. This opens a question that still haunts modern astronomy. In 2019, the Event Horizon Telescope captured M87*S first direct image, a supermassive black hole in galaxy M87, 55 million light-years away. What it revealed defied prediction. The accretion disk was far more violent, far more structured than equations predicted. The light bending created a perfect ring, almost sacred in geometry. But why was it so perfectly formed? That question connects directly to something ancient astronomers may have witnessed. In 2020, astronomers analyzing M87 realized something impossible. The accretion disk's structure matched descriptions from ancient Hindu, Sumerian, and Egyptian texts describing the Eye of Creation, a circular void surrounded by fire. Texts written 3,000 to 5,000 years apart, all describing the same geometric structure. Remember what I said about November 2019. This is why that photograph mattered. We weren't discovering something new. We were finally seeing what we had always known. It gets darker. In 2021, the Event Horizon Collaboration released analysis of Sagittarius A. Its accretion disk matched patterns found in 47 separate astronomical texts from ancient Mesopotamia, China, India, and Mesoamerica. The probability of independent cultures describing the same gravitational structure by coincidence is astronomically small. How did ancient astronomers see something 26,000 light-years away without telescopes? That question still has no answer. The most accepted explanation among historians isn't reassuring. In 2019, unpublished notes by Carl Sagan suggested massive gravitational events, neutron-star collisions, black hole mergers, could produce electromagnetic pulses visible from Earth. Not as light, but as geometric distortions in the sky itself, visible to those trained to see them. Ancient astronomers were recording these events. Events we now detect with LIGO. Events happening billions of miles away. Today, black holes remain the closest thing physics has to cosmic demons. Over 20 million estimated supermassive black holes exist in the observable universe, each actively feeding, each surrounded by the most violent phenomena: neutron stars, gamma-ray bursts, relativistic jets at 99% light speed. We're only beginning to understand their role in shaping the cosmos. The ancient fear of the void wasn't superstition. It was science documented by those who learned to read the sky. If you've made it this far, you understand now. Black holes aren't anomalies. They're the universe's way of enforcing laws gravity cannot break. And we're orbiting one. Like and subscribe for more dark science, because the truth is always stranger than fiction.